Welcome to this video, where we will show how our example company, TCN, uses our prototype during their development of the peer-to-peer reconnection feature. In the presentation, TCN went through one iteration of this feature. I will show this first iteration in the prototype, showing you how it can be used to set everything up and get started before we continue with the second iteration. This is the landing page, where you can see a short video, similar to this one, on why the prototype was built, what problems it addresses, and how it works. And here on the right side you can see our process model that the prototype is built on, and we will revisit that one several times throughout this video. Now let's get started. The first step is to select a feature here. And for this example we have peer-to-peer reconnection. Now we have selected the feature, and then we go to the second step, a model. Here we add the factors of the feature, and for each factor we need a name, its starting state, the unit of change, the value constant, and the unit of the factor. And as we saw, one of our factors had an unknown starting state. But when advancing with the model, we get the starting state once the instrumentation has been set in step 4. Therefore, for the sake of simplicity, we assume that TCN has done that. That is, they have gone through the first, second, third, and fourth, used this loop here, and are back at the model step. Now let's add the factors and the values. The first factor is reconnects per hour. The starting state is 10, the unit of change is -1, the value constant is 300, and the unit for the factor is hours. Okay, then we have the second factor, reconnection time. The starting state is 10. The unit of change is -0.1, the value constant is 100, and the unit is milliseconds. The third factor is user safety. The starting state is 3, the unit of change is 1, the value constant is 1200, and the unit for the factor is an absolute value from -5 to 5. Now that we have finished the modeling part, we are at the third step, predict. Now we need to go into each factor using configure. There we can update the factor, as well as add estimations and measurements. But measurements can also be added through an import function that we will show later. And as we are in the predict step, we're going to add an estimation for every factor. We estimate that we can get down to 8 here for reconnects per hour. For the reconnection time, we estimate that it can be 8.5 milliseconds, and we don't expect the user safety to change at all. This is just an important factor that we want to pay close attention to. Alright, so now we have predictions for each factor, and then you can see here that the predicted value for the feature is 2100. Then we need to go down here and set a tolerated gap for the feature. It can be set either as a percentage, so if you would add 10%, we would be fine with a predicted value of 10% less than the actual prediction, or as an absolute value, which we will discuss later on. Now we set it to 10% here. Now steps 4 to 7 in the process model are not a part of the prototype as such, as the actual instrumentation needs to be done in TCN's system. The implementation is then carried out, and the feature is deployed and monitored. And as TCN got an unexpected value when they starting analyzing the data in the 8th and last step in the iteration, we need the fourth factor, packet loss, along with its values, and add the predicted value as well. So we go back here, or go forward here to model. We add packet loss, starting state is 0.4, the unit of change is -0.1, the value constant is 100, and the unit here is percentage. Then we continue here to predict, and we set the prediction to 0.1, and then we don't have to do anything here in 4, 5, 6 and 7, so we use the shortcut here and go to analyze directly. So now what we have set the estimated here for the packet loss, we can see that the prediction has gone up to 2400 when adding the fourth factor. But DCN wants to keep the old threshold, so we update the tolerated gap and set it to 1890, and then we select the absolute value here. And once the realized values for the factors have been retrieved, we can import the data into the prototype. We start with the first iteration here, and then we can see, if we go here to the graph, that it has gone up from 0 initially to 1600. And threshold here is 1890 and the predicted value is 2400. So we are a bit behind. And as was mentioned in the presentation, DCN has decided to go through another iteration as they think they will be able to go over the threshold. Alright, so we go through the model again. Nothing needs to be done in steps 2, 3 and 4. That is model, predict and instrument. But we extend our minimal viable feature in the 5th step, then we deploy it and we monitor. We do not get any unexpected value at this time, so we can go straight to importing the measurements. And here is the second iteration. We import it, and now we can see that DCN has broken the barrier. They are above the threshold, and as you can see here, if we go, the feature is ready for wide deployment. Realized value is 1900, the gap threshold is 1890, but our prediction was 2400. So they are ready for wide deployment of their peer-to-peer reconnection feature. Thank you for watching this video.